When you think about a next-gen factory, what comes to mind? Probably clean rooms, super advanced robots, all that cool machinery, right? But the real innovation, it starts way before any of that gets installed. It actually starts with the building itself, this invisible, incredibly engineered system that makes everything else possible. So today, we're going to pull back the curtain on the technical engineering that is truly powering the future of manufacturing.
You know, this quote right here, it gets straight to the heart of it. We all know the names of famous architects, of course. But seriously, can you name the engineer who made their vision actually stand up? The person who made sure the whole thing was safe, that the climate was perfectly controlled, and that all its complicated systems worked without a hitch? Well, that's the thing. These are the unsung heroes of construction.
And that's the big question we're tackling today. We're going to explore who these engineers are, the step-by-step journey they take, and the almost digital superpowers they use to turn an architect's sketch into the kind of high-stakes, next-generation facility that literally builds our future.
All right, so let's start with the fundamentals. Without this discipline of technical engineering, the really complex buildings that define our world, we're talking everything from airports to advanced factories, they just couldn't exist. It's the essential backbone holding everything up and making it all work.
So what is technical engineering really? Well, in short, it's the science of making things work. It's the whole skill set you need to study a concept, design all of its functional parts, and then make sure it can actually be built on time and on budget. Think of it like a bridge between a simple idea and a super complex physical reality.
Now, a massive project is never a solo act. Not a chance. It takes a dream team of specialists, and every single one plays a critical role. So let's meet the key players who have to work together perfectly to bring a complex facility from just an idea into a real thing.
It all kicks off with the client, or as they say in French project management, the maître d'ouvrage. This is the company with the big vision. They're the ones who say, hey, we need a new microchip factory. And most importantly, they're the ones holding the keys to the budget.
Next up, you've got the project lead, or maître d'œuvre. And listen, this isn't one person, it's a whole team. Their job is to take that client's vision and create the complete plan, architectural, technical, and economic, to make it happen. And this team is really built around a core partnership.
And this slide illustrates that partnership perfectly. On one side, you've got the architect, focused on the vision, the form, the flow of the space, basically the what it looks like. And on the other side, the engineer, focused on all the technical solutions that make it possible, the structure, the climate control, the energy, the safety systems, the how it works. They're two sides of the exact same essential coin. You can't have one without the other.
So, how does this dream team take a project from a simple idea to a fully operational building? Well, it's not magic. It's actually a very structured journey with clear phases and milestones.
At the highest level, you can break the entire life cycle into two main parts. First, you have the studies phase. This is all the brain power, right? The designing, the planning, the calculating. Then comes the works phase, and that's when the shovels hit the ground and the physical building starts to actually rise.
But if we dive a little deeper, that studies phase is broken down into 4 really crucial steps. It starts with a simple sketch, just to explore some initial ideas. That then evolves into a preliminary design where the concepts get a lot more concrete. From there, it's refined into the final project design with all the detailed specs. And finally, it becomes the execution plans, the master blueprints for construction.
Okay, now for the really cool part. To solve the unbelievably complex problems of modern buildings, engineers are using some amazing digital tools. You can think of these as the superpowers that let them see the invisible and, well, build the future. Take a look at this concert hall. The same technology that makes sure the airflow and temperature are perfect in here is absolutely critical in advanced manufacturing. I mean, just imagine a clean room for making semiconductors, where a single speck of dust or tiny 1-degree shift in temperature can ruin millions of dollars of product. Engineers use this exact same climate simulation software to model those incredibly precise environments before a single wall even goes up.
And this is where it's just non-negotiable for next-gen manufacturing. A microelectronics factory is like a dense 3D puzzle of pipes and wires and ducts. So using 3D modeling, engineers do what's called synthesis, which is basically layering all these complex systems together digitally to make sure they fit perfectly. This is what prevents clashes that could cost millions and cause huge delays during construction.
So you can see, this work is so much more than just solving technical puzzles. It carries an immense amount of responsibility. The decisions an engineer makes today will impact people's safety and the environment for decades to come.
And the stakes are incredibly high. Just look at this number, 10. That represents the years of legal liability that engineers and architects in France carry for their work after a project is finished. That is a full decade of accountability, a constant reminder that safety and quality are absolutely non-negotiable.
And you know, today, that responsibility goes way beyond just making sure a building doesn't fall down. The engineering profession is really at the forefront of creating a sustainable future, using smarter design, more efficient systems, and innovative materials to build a greener world.
So, let's end with the new way of seeing things. The buildings that power our future, they aren't just shells. They're complex, living systems. The next time you pass a modern factory or a lab, look beyond the walls. Try to see the invisible network inside, and maybe remember the unsung engineering heroes who designed our world.